Next problem. See here. So whatever the problem you have seen previous three problems, it is the composite valve. We are going to calculate the temperature distribution on the composite valve. One end it is subjected to some temperature, another end it is subjected to some ambient temperature. That is one type of problem. We are going to calculate the temperature distribution. But this is the another type of problems, that is based problems on fins. Now here you can see, find the distribution in the one-dimensional fin shown in the figure. Take two elements for a FEA model. So they have given one element. We have to consider as a two element in order to solve the problem. Now we have to consider two elements. If you consider this as a two element, then we will get the three nodes. Node 1 at this point, node 2 at the center, node 3 at this point. So now it is fixed at this point, and at this point the temperature is equal to 140 degrees Celsius, and this complete fin is subjected to some ambient surrounding temperature. So T infinity is equal to 40 degrees Celsius, and the cross section is circular, and they have given 1 centimeter radius, and they have given a convection heat transfer coefficient and thermal conductivity. So the difference for previous problem and this problem, in the composite wall problem, only any one of the end is subjected to ambient temperature, but this fins problem, the complete fin is subjected to surrounding temperature or ambient temperature. So now this is the problem. Now we have to convert the given problem into a FEA model. Same procedure. So they told you to divide this into two elements. Then we will get node 1, node 2, node 3. Node 2 exactly at the center. Then we will get T1, T2, T3. 1 to 2 element 1, 2 to 3 element 2, L1 and L2. So same procedure. First calculate the stiffness matrix for the convection. So this formula is Ka by L, 1 minus 1 minus 1 into 1. So first calculate the stiffness matrix for element 1. So here you can give the numbering 1 2 1 2 or T1 T2 T1 T2. Then calculate the stiffness matrix for the element 2. You can give T2 T3 T2 T3 or 2 3 2 3. That is your wish. Now we got K1 and K2. Then we are adding total K1 plus K2, T1 T2 T3. T1, T2, T3, then we will get the total K matrix. Next, now this is the stiffness matrix based upon the conduction. Same thing, we are going to calculate stiffness matrix based upon the convection. So the formula to calculate stiffness matrix based upon the convection is KH is equal to HPL divided by 6, 2, 1 minus 1, 2. Now, so for composite problems and this fins problem, the difference is the formula of convection. Formula is difference. Why means there it is subject, if composite wall at only one end it is subjected to surrounding temperature, but here complete fin is subjected to some surrounding temperature. Therefore the formula is difference. Therefore here H is nothing but heat transfer coefficient, convection heat transfer coefficient. P is nothing but perimeter. L is equal to length. Now perimeter we are going to calculate. The formula to calculate perimeter is equal to 2 pi r. Now same thing we are going to calculate both for element 1 and for element 2. So we are going to calculate for element 1, we are going to calculate for element 2. Here same thing, T1 T2 T1 T2 T2 T3 T2 T3. Then we are going to add both. Then we will get the total K matrix, the stiffness matrix for convection. Now this is the stiffness matrix for conduction. This is the stiffness matrix for convection. Now we are going to add these two matrix. Then we will get the global stiffness matrix. Therefore, total global stiffness matrix is equal to adding of conduction stiffness matrix and convection stiffness matrix. Then we will get the total global stiffness matrix. Now K is over. Next we are going to calculate the force matrix due to convection. FH is equal to H T infinity PL divided by 2 minus 1 into. Again, the formula is difference to calculate the force matrix compared to composite wall and the fins problem. So this is the formula here. H is convection heat transfer coefficient, T infinity is equal to ambient temperature, P is perimeter, L divided by 2. Same thing we are calculating for element 1 and element 2. So here we are going to give numbering T1, T2, T1, T2. Then we are going to add these two. Therefore, total F is equal to, you are going to write the number T1, T2, T3. Now if you take T1, so only here we are having T1, write that value. Next, if you go for T2, so here we are having T2. Again here we are having T2. Add these two, then you will get T2. Again here we are having T3. So here we are having T3. Then you will get the T. So this is the force matrix. Now K into T is equal to F. Now in this problem, we know the value of T1. So they given in the question T1. Therefore, eliminate particular row, particular column, first row and first column, then simplify, then calculate. They are known T2 and T3. So then we will get T2 and T3. You can calculate in degree Celsius or you can calculate in Kelvins. Understood?